Hey everybody, today we're going to talk about dividing powers. This is section 7.4. We're skipping 7.3 for now. We will be going back to it, but I wanted to talk about dividing powers next. So 7.4 is all about dividing powers. So just like yesterday, I'm going to show you how we can simplify a division problem where we're dividing two exponential expressions by expanding the expression. Then we'll see a shortcut, and then we'll apply that shortcut to solve a series of examples. So let's start out with by considering 3 to the power of 5 divided by 3 to the power of 2. So I've got a power in the top, 3 to the power of 5, a power in the bottom, 3 to the power of 2, and I'm going to simplify this expression. I can rewrite it as just one power. And just like yesterday, it's important that the base is the same for each of these. So I can simplify this because they both have the same base, meaning that they're both, the large number in both cases is 3. So I'm going to start by expanding the expression. Now we don't always have to expand, but since we haven't learned the shortcut yet, we're going to figure it out by expanding this out and simplifying from there. So I can rewrite this as literally 3 times 3 times 3 times 3 times 3. So that's what 3 to the 5th power means. 3 times itself 5 times. And in the bottom we have 3 times 3. We know that if I divide any number by itself, that's equal to just 1. 3 divided by 3 is 1. So if I have a 3 on the top and a 3 in the bottom, then I can cancel those out because they really just make 1. Now, remember that if there was addition or subtraction involved, if this was 3 plus 3, then we wouldn't necessarily be able to cancel it out. But because this is all multiplication, it's actually just fine for me to say that if I have a 3 in the top, that's going to cancel out with the 3 in the bottom. If I have a 3 in the top, that's going to cancel out with the 3 in the bottom. Which means I'm left with 3 3's in the top and nothing in the bottom, or 1 in the bottom. So I've got 3 times 3 times 3, which I could write as 3 to the 3rd power. It's not a coincidence that 5 minus 2 is 3. What we've learned here is that if I divide two powers with the same base, I can find the answer is going to be found by finding the difference between the exponents, which should make sense. Yesterday, when we multiplied powers, we learned that we can just add their exponents if they have the same base. So if I'm dividing two powers, I subtract the exponents. So what we need to do next is some examples. Let's say that we wanted to simplify the following expressions, and I'll write them all out and we'll knock them out one by one. So let's say we have x to the 7th power over x to the 5th power. Let's take a look at the reciprocal of that, x to the 5th over x to the 7th. And then we'll have an example where there's some numbers thrown in there as well, like 5a to the 3rd power over 10a. So you might have noticed that I didn't actually write a property of exponents like I have in the previous lessons. There is a property of exponents to help us remember the rule about dividing powers, but I've come up with my own way of going about these problems that I think is much more helpful for students. It results in a lot less confusion. My strategy is to subtract the smaller exponent from the bigger exponent. So in this example here, the smaller of the two exponents is 5. So I'm going to subtract 5 from 5 and 7. And how I show my work here is I'm going to cross out the 5 and write 0. 5 minus 5 is 0. Cross out the 7 and write 2. 7 minus 5 is 2. As a result, what I have is, in the top, x to the power of 2 over, in the bottom, x to the power of 0. x to the power of 0 is just 1. Anything to the power of 0 is just 1. So that's x to the power of 2 over 1. And because 1 is in the denominator, and dividing by 1 does not change anything, I could also just write this as x to the power of 2. This next problem, I'm going to do the same exact thing. I'm going to subtract the smaller exponent from the larger exponent. The difference this time is that the x to the power of 2 is in the bottom of the fraction. So again, x to the power of 0 is 1. X to the power of 2 is x to the power of 2. This time, I have to leave my expression as a fraction. If the 1 is in the top of the fraction, then we can't just forget about it. Because while x to the second power divided by 1 is x to the second power, 1 divided by x to the second power is not equal to x to the second power. And that should make sense. It would be kind of weird if these two very different problems had the same solution. So this is how I'm going to leave my answer. 1 over x to the second power. Okay, for this last one, let's start out by putting a 1 above the a in the bottom. It didn't have an exponent, which means its exponent is 1. So again, we're just going to subtract the smaller power of 1 from both powers, which means that we'll just have a to the power of 2 in the numerator. As for the big numbers, we're just going to reduce the fraction. You know that 5/10 is the same as 1/2, so we're going to reduce 5/10 to 1/2. In other words, we're going to be dividing each of the big numbers by a common factor. So I can divide 5 by 5, and I can divide 10 by 5 as well. And so what I have here is 1a to the second power over 2, and then the other a is gone now. You could leave your answer as 1a to the second over 2, or you could forget about that 1 and just write it as a to the second over 2. Okay, so I just want to do a couple more slightly more complex problems, and then you guys are going to be working on some more practice problems of your own. And just like the last, well, maybe not the last assignment, but this is an assignment where the answers are going to be included on the page. So you guys are going to be able to check your work as you go. But as usual, they're jumbled and there's a few extra solutions mixed in. So as you go through each problem, just look on the back of the assignment for today and see if your answer's on there. If it is, cross it off. If not, then you may have done something wrong and you need to go back and check. All right, so like I said, let's do a slightly more complicated problem here. So let's say we wanted to simplify (12) a to the negative 5th power times b to the 2nd power, all divided by 9 a to the 2nd power times b to the 4th power. I'm going to write this as a step-by-step process to help you guys out today. The first thing we want to do is move the negative powers. I've got a negative exponent involved in this expression. And so the first thing I want to do is move that negative exponent so that I can turn it into a positive exponent. Now the reason why I want to do that is because it's going to be kind of hard to figure it out if I jump in by, so let me rephrase that. We just learned that we need to subtract the smaller exponent from each of the exponents. but if one of them's negative, that means we're going to have 2 minus negative 5, which some of you guys might say, oh, well, that's just 7. And then you could use that strategy. But I think it's easier to just move the negative exponents so that they're positive numbers, so that we don't have to work with subtracting negative values. So what I'm going to do is I'm going to leave everything else alone. The 12, the b to the second power, the 9, the a to the second power, and the b to the fourth power. None of that's going to move for this first step. Now, you might learn that you can do multiple steps in one go, but you guys know how I like to do this. I like to go one step at a time. So all I'm going to do here is move that a to the power of 5 into the denominator. And notice that I'm just sticking it at the end there. Multiplication is commutative, so that a to the 5th power can go in any position in the denominator. I'm just sticking it right there at the end. So I took that a to the negative 5th power, I moved it across the fraction bar, and now it's a positive a to the 5th power. So now that I've moved my negative powers, I'm going to cancel terms. What I mean by that is I'm going to subtract exponents. I'm going to subtract the smaller exponent from the larger exponent for each of the powers, and I'm going to reduce the fraction. So let me rewrite the problem that we have so far. And what I'm going to do is I'm going to look for, first, if I have a variable on the top and the same variable on the bottom. So here I have b to the second on top. I have b to the fourth on bottom. So I'm going to subtract the smaller power from the larger power. And so I won't have any b's in the top anymore. I'll just have b to the second power in the bottom. I've got a big number of 12 and a big number of 9. 12 and 9 can both be divided by 3, so I'm going to do that. I'm going to cross out 12 and write 4, cross out 9 and write 3. All I'm doing here is I'm reducing the fraction. 12 over 9 is the same as 4 over 3. And so what I end up with is 4 over 3, a to the second, b to the second, a to the power of 5. If you're wondering what happens to the other b in the numerator, remember that guy's gone. B to the power of 0 is just 1. So we have 4 on the top, and that's it. So oftentimes, if you fall, at this point you may be done, but I'm not finished until I have only one of each variable. So when you guys are working through the practice problems today, know that all of the answers will have just one of each variable. So I have just one b, but I have these two a's, so I'm not quite finished yet. So that's why I'm going to add on this third step to finish simplifying. Now, I think that I made the problems on your guys' assignment such that you may not need, this may not happen. We're going to have more complex problems later on where you may need to do all three of these steps to simplify the problem completely. I don't believe I put any practice problems like this one on the assignment. You're going to be mostly moving negative powers and canceling terms today. However, if I am mistaken, or if you choose to simplify in a way where you end up with more than one variable on one side of the fraction, remember that we just have to add the exponents together. So I've got 4 over 3, and now I'm going to write this as a to the 7th power, adding the 2 and the 5, and then it's still just b to the 2nd. And that is my final answer. How I know I'm done is because I only have one of each variable and just one big number in the top and one big number in the bottom. Okay? So go to it. Good luck with your assignment today, and don't forget that the answers are provided on the back.